In this video, I want to explain how the function map works in R and how it lets you vectorize functions that are not vectorized out of the box. To start with, here's the function paste0. What paste0 does is it takes two character strings. The first character string is hi, my name is, and the second character string is Colleen. Paste0 pastes without any characters in between. The 0 is for no characters in between them. Hi, my name is Colleen is pasted together. That's what paste0 does. Now, paste0 is conveniently vectorized. Let's see that here. I call paste0 again. This time, I'll call it a vector of length 3, all character strings. The character string, hi, my name is, with the character string, do you know, the character string, how is, and all of those are going to be pasted with Colleen to finish it off. So this returns, hi, my name is Colleen, do you know Colleen, how is Colleen? So you can see paste0 is vectorized. This is a vectorized function because it works with just one character string pasted onto another, or you can put in many character strings and paste onto another string. So this function is vectorized, and you can play around with this function on your own. For example, this is very useful. You can see here, loaded the tidyverse and then made a data set with x going from 1 to 10, and then z, I've just pasted on to x the character string cm. So I've used the fact that paste is vectorized to apply it to this vector, x, and now instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, now I have 1 centimeter, 2 centimeters, 3 centimeters. So the paste is very useful. You can use it in this context. Now I'm going to talk about a function that's not vectorized. Write.csv is not a vectorized function. Here's how you call write.csv. You have a data set, iris. You can say write.csv iris, and then put a character string for where you want to save that and how you want to name that data set. And then you can write a CSV after you call this line of code. A data set called iris.csv is saved in your working directory. That's a very useful function when you're working on a data set and you want to save it to your computer. That's how you do it. Now, if you have multiple data sets and you want to save all of them to your computer, suppose we have the data sets iris and empty cars. And in one line of code, we want to save them both. I want to save iris under iris.csv and empty cars under empty cars.csv. Maybe we have 50 data sets that we're working on and we want to save all 50 to our computer with one line of code. Write.csv is not vectorized, so this will return an error. What's the solution? How do we make this unvectorized function vectorized? The answer is we can use map. It's a bit more complicated because I actually had to use map too to solve this problem. We're not just iterating over one vector, it's the data sets and the names of the data sets that I'm going to save. So here's how I solved this problem using, you have the first vector you want to iterate over, the second vector you want to iterate over, and then the function you want to apply. It's map too, so I am referring to both .x and .y. Now, let's get a little bit more into how map works. Here's a really nice diagram you want to keep in mind when you're using map. So the idea is that the function f that you want to vectorize doesn't come vectorized out of the box. If it did, you could just say f and then c, whatever we want to iterate over, x, y, z, and then that would return as x, y, z. But the idea is f is not vectorized, so we can't just call it on a vector. Instead, we use map to make f vectorized. And all map does is it takes f and it applies f to every element of this vector. The idea is the f is what you keep the same. This .x vector is what you want to change. All map does is it takes your function s and applies it to every element of the .x vector. Returns this list of f applied to every element of .x.